Whoops. Okay, in this lecture, we're going to be going over measures of location. More specifically, we're looking at measures of central location. And we've got three measures of central location that you might already be fairly familiar with, and that's the mean, median, and the mode. And so, because we are pretty familiar with it, I'm not going to spend too much time on explaining what those are, but understanding a little bit more about what location means. So by the conclusion of this lesson, what you're going to be able to do is compute and interpret the mean, the median, and the mode. And you're also going to be able to compute a weighted mean. Then another thing that we're going to chat about is interpreting a geometric mean. That's really important right now, I guess, with GameStop and all those crazy things, the average gains over time, and so on and so forth. And yeah, we'll talk about that. The geometric mean is a little bit different. So measures of location. Now, it's really important to notice that data has a location. In other words, how a piece of data is positioned in relation to all the other pieces of data. And then it also has a value. So data has a position and it also has a value. Data is relative to the position is relative to every other piece of information or every other piece of data, and the value is just the value in and of itself. Okay, so common measures of location are the mean, median, and mode. And what normally when we say mean, what we're saying is the arithmetic mean. In other words, you just take the general average of all the values that you have. That's the arithmetic mean, which is the most widely reported. Let's see if I can get out of the shot. Widely reported measure of location. Okay. Um, let's see here. And so we've got a formula here. We've got the sample and the population mean. They're pretty much the exact same thing. Once again, when we have the population, we're using Greek numbers or Greek, and then when we have sample, we're using just normal English notations. And so you can see that's how the formulas are written. Another really important thing to notice that we need to be paying attention to is the concept of a parameter versus a statistic. So a parameter is for a population. Notice P and P, and let me get this dinosaur out of the way. Okay, so a characteristic of a population and a statistic is a characteristic of a sample. And so when we have a parameter, what we're saying is we've got some information about the larger population. When we have a statistic, we're saying, okay, we've got this piece of information, but it's about a sample from the larger population. So not necessarily the larger population. Okay, so here is an example of a population mean. Okay, there are 42 exits on I-75 through the state of Kentucky. Listed below are the distances between the exits in miles. Now, the reason why this is a population mean is because literally every single exit is listed. Every single exit is listed, and because every exit is listed, it's a population. Mind you, there's only 42 of them, but it's still a population of 42. Now, something that I want you to notice is right here, it doesn't give us the location of where they are necessarily, um, but we'll get to that in just a minute. But you could have like the first, the second, the third, but yeah. Okay, so Verizon is studying the number of minutes used by clients in a particular cell phone rate plan. A random sample of 12 clients showed by the following number of minutes last month. And so you've got 90, 91, 77, 110, 94, 92, 89, 100, 119, 113, 112, and 83. So in order to get the arithmetic mean of all of these, which we're still just talking about the mean, you add up all 12 of these together, and then you divide it by 12. It's a pretty simple concept. You just add them all together and divide it by the total number that you have. And this is something that you're probably very familiar with. And so we're not going to spend too much time on that. Okay. Now what I do want to show you guys though, is right here we've got 90, 91, 77, 94, so on and so forth. Okay, so there are a total of 12 values here. That means that there is a total of 12 positions. So data has values and it also has positions. So you order them from least to greatest. And so if we want to have a total of 12 values, we would start right down here and we would say, okay, the lowest value is 77. And notice there's a total of 12 balls here. And I've got this super cool dinosaur, which has all the rest of the balls, but that's okay. We don't need those. And so my son's graciously permitted me to use this. So if you put these in order, we've got the one in value, or the one in position one is going to be the lowest one, which is going to be 77. And then from there, we're going to go up. The next one is 83. Okay. And then let's see here, 83. What comes after 83? We're going to go with 90. So we've got a 90. Oops, they're falling off. 90. And then we've got a 91. Then we've got 92. Is there a 93? Nope. 94. Oh, I skipped over 89. Whoops. But you guys get what I'm saying. It's you put them in order from least to greatest, where every single one of them has a value. So this has a value of 77. This has a value of 83. This has a value of 89. And all the rest of these in order also have values. And so, but they also have positions. This is position 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's really important to to know that when you put data in order, you deal with positions and you also deal with values. And I will ask you for the positions and I will ask you for the values. So properties of the arithmetic mean, it's interval or ratio. In other words, you've got to be able to do math with it. All the data values are used in the calculation. It's unique. The sum of the deviations from the mean is equal to 0. In other words, if you take the mean of all of these values, um, and then you look at how far each one of these deviates from 0, so or deviates from the mean, this will deviate, or this will deviate with a negative. This will deviate with a positive. This will be greater than the mean. This will be less than the mean, less than the mean, less than the mean, less than the mean. But you add up all of those deviations together from the mean, and it will all equal 0. We'll talk more about that later. And then a weakness of the mean is that it's affected by extreme values. So in other words, if you had this one and it's all the way over here, and you have this one and it's all the way over here, it affects that mean that's in the middle. You average all of these together, or you go like this, and you have this one all the way down here. It's going to pull all the rest of these down towards that one. So it's affected by extreme values. Okay, so the median. The median, the midpoint of the values after they've been ordered from the minimum to the maximum values. Like I said, I've already got these min to max, and because I wanted to show you guys the value versus position. So we've got the median, and so we put them from minimum to maximum. Like for instance, if I were to say to you, okay, we've got a list of five flats in Waco. These are the prices for 5 flats in Waco, and so it's 60,000, 65,000, 70,000, 80,000, and 275,000. And so maybe 275,000 is that flat that's right across from Magnolia Market, and the 60,000, those are the normal typical ones, and then you've got one that's an outlier. And so you put them from minimum to maximum, and then you've got the median, and the median is going to be right in the middle of all of them. Or if you have an even number, then you take the average of the two middle numbers. So if we had one more number down here, so if we had a 300,000, then it would be the average between 70 and 80, so it'd be $75,000. Okay. So characteristics of the median is the value in the middle of a set of ordered data. At least the ordered scale of measurement is required. So we've got to have at least ordinal. In other words, you can have things that are in order: first place, second place, third place, fourth place, fifth place. It doesn't have to necessarily be numerical. You could also have least likely to most likely. But if you have least likely to most likely, you can't average, if there's six possible choices, you would have to say, okay, there's two medians, if the median is in between the two. But we can get to that a little bit later. That one's actually a little tricky to show you exactly how it works, but essentially um, you put all of the counts of all of the qualitative classes in order, and you find the one that's right there in the middle, and that's going to be the median. Um, so I think I have a video that shows you how to do it in Excel that shows you much more explicitly how to do it. So 50% of the observations are above the median and 50% are below the median. And also it's unique to that set of data right there. So that's the characteristics of the median. Also, when you pay attention to the formula sheet, you'll notice that it says, okay, what you can do with the median, the mode, and um, the mean. Okay, so with finding the median, like I said, put them in all in order from. So we've got 3, 5, 7, da 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 da. Find the median by putting them all in order from least to greatest, and this is what I was talking about earlier. So this has a total of 10 adults. So you find 5. So 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. And so it's between 5 and 7. And so in order to get the median there, the median is going to be 6. Okay. Um, so the number of hours a sample of 10 adults spent on Facebook last month. So the median is going to be 6 because when we put them in order from least to greatest, that's what's in the middle. Okay. So the mode is whatever occurs most often. And with the mode, you can literally use any kind of data. Um, as long as there's more than one observation of each type of data, or of at least one type of one variable or whatnot, you can use the mode. So the mode is essentially whatever occurs most often. So the mode can be nominal data, ordinal, interval, ratio, and also a set of data can have more than one mode. So if you have more than one mode, that would be referred to as bimodal data or trimodal data. If you have more than that many modes, then you probably shouldn't be dealing with that. But you can have bimodal data. So say for instance, right down here, the value of observations that occurs the most frequently. You've got amor, l'amour, soothing, smell nice, far out, the number of responses of the favorite type of bath oils. And so I guess l'amour is the mode because that's the one that occurs most often. Okay. Now we're not going to cover this all too much. We're going to go over this a lot more in the next lesson, but we have shapes of data. Okay. And with shapes of data, you can compare the median to the mean. And when you compare the median to the mean, you can tell, okay, is this data pretty normally distributed in a way that's really easy to interpret? Or is this data really positively skewed, really negatively skewed? And if the mean is greater than the median, and this is really important. Okay, so always say it like this: if the mean is greater than the median, it's positively skewed. Okay. If the mean is greater than the median, it's positively skewed. In other words, right here, it means that the data is moving like really heavy on the far right-hand side and it's skewing towards that direction. Okay. If the mean, let's see here, if the mean is less than the median, then it's negatively skewed. And so when it's negatively skewed or when it's positively skewed, it's a little bit more difficult to interpret. And what we want is we want something where the mean, the median, and the mode are all the same, and it makes it really easy to interpret. Okay, let's see here. And that would be called a symmetrical distribution or a normal distribution. And the mean is greater than the median. The way to remember that's really easy is mean. It comes alphabetically before median.